everyone, welcome to All Techies. I'm Pankaj Rai, and in this video I'm going to talk about Kotlin coroutines. If you have never used coroutines before, then it really doesn't matter because I'm going to start from the beginning. But before I proceed towards coroutine, the first thing is that why we are even talking about it. So coroutine you can think as the replacement for all the threading mechanisms that we have used with Android before. However, for certain cases, if you are using executors, then I would say that you can continue using that. But for most of the scenarios, like using async task or any other mechanism which you might be using to switch to another thread, I would strongly suggest to switch from that mechanism to coroutines. And the reason is that this thread, even though they are lightweight, they are not that lightweight actually. Rather, these coroutines are really very lightweight threads. Here, it takes an advantage of the running threads and they just reuse those threads. However, there is one major difference between coroutines and threads. Coroutines are corporatively multitasked, which means that it's a style of computer programming where operating system doesn't switch the context from one process to another process. However, threads are preemptively multitasked, which means that every task is given certain time, and after that operating system switch the task from CPU with another task. So by that way it do a context switch between the processes, and because it's doing that kind of work, so it's quite heavy. But here with coroutines that's not the case. All the things are going on in the single process, and that's why if you try to create say 1,000,000 coroutines, that's still possible. But if you try to create 1,000,000 threads and try to run it, then I'm sure you'll not able to run your system also properly. So that's really important concept, that if you are using coroutines, then because of the advantage that comes with the coroutine, the lightweight concept of thread, so you take an advantage of coroutine. Plus, if you attach to the live data, get the content, and then set the live data and observe it in your activity or fragment, you can do lots of great things. Also by making it context aware, because coroutine by default is not context aware. This is just a mechanism where you could do synchronous programming or asynchronous programming. So let's see how we can add coroutines to our Android application. First, switch to Gradle and add the dependencies for coroutine. Also, I will strongly recommend to add this library. Lifecycle-runtime-ktx 2.2.0 is the stable version, and then we just have 2.3 in the alpha. So rather than using alpha, I would strongly suggest to use 2.0 in your production application. So the moment you have these three dependencies, you can get most out of the coroutines. Here, I'm not talking about live data and view model that I am going to talk in the upcoming videos, but the main focus here for this video is coroutine. Okay, now let me talk about the individual libraries also. Coroutine cores give us all the core APIs that coroutine is requiring for our application. This is required to switch between the context, so that here in the main activity or in the fragment, we can switch between the main thread to the background thread. This KTX, runtime KTX, is really helpful for us if we want to give the lifecycle scope. So one thing with coroutine is that it depends on the lifecycle scope. In most of the sample application, you might have seen something like as global scope. This might be good with the Java applications, but for Android application, I would say never ever use this one. Well, the reason is that it's a global scope, which means that this is the scope attached with the life cycle of entire application. But because our activity or fragment have life cycles, so having global scope is really not useful for us. So what should we use? Because without providing scope, we cannot start coroutines. That is why I have added lifecycle-runtime-ktx. With this library, I can add something like lifecycle scope, and on that lifecycle scope, I can call any coroutine builder, either launch or async. Launch, and let me also write about async. Now, when to use this? It's for the synchronous programming, and this is for async, as the name suggests. So if you want to execute certain thing one after another, you should use launch. And if you want to execute it by any order, the order doesn't matter there. Asynchronously you want to execute certain things, then you can use async. However, these two were the initial coroutine builders that we had, but now we have more than this. Let me talk about launch first. Now, one thing which you might have noticed is that I'm saying launch as a coroutine builder but not a coroutines. And the reason is that coroutines are created for you. So whatever functions or the code which you're going to write here, so that will be part of coroutines. And to start coroutines or to create coroutines, we need coroutine builders. And launch and async are the coroutine builders. Okay, now let me talk about what other coroutines builders that we have because of this library. So lifecycle scope dot launch when started. Lifecycle scope dot launch when resumed. Lifecycle scope dot launch when created. These three are really useful coroutine builders. They are all part of launch with an extension of like when created, when resumed, when started. But when you already have launch, why should we need these three coroutine builders? So as the name suggests, whatever you write here in this block, this gets executed only when the state of this life cycle is on started. So this part remains suspended until the life cycle is on started. Even though you're writing this in on create, still it doesn't matter. It will suspend the execution until the state matches with on start. Same way, you may write all piece of code, whatever you want to execute in on resume, and whatever you are writing here, this will get suspended until the life cycle is on resumed. And here it's on create. Now, who should get called first? I could also have like on start and on resume. So initially it starts with on create, then on start, and finally on resume. We also have defined this inside our on create. So whom should get called first? Either the piece of code written in this coroutine builder or the code written in this on start. So initially, because this is the state, so state gets called first, and then whatever you define it here, this will get executed later on. Okay, so that was about the coroutine builders. So before I conclude this video, the final concept which I want to tell here, and then in the next video I'll talk more about how to use this launch and async, what's the difference between both of them. The final concept here for this video is suspend. So suspend function is useful if you want to call function which is having suspend keyword in that. So suspending function can only be called from other suspending functions or from the coroutine builders. Say if I have a function called as get delayed, and then I could call a delay method, which is nothing but a suspending function. So it is important for me to mark this function also suspend. If I do not do it, that will throw an error that it's not permitted. Suspend function should only be called from a coroutine or another suspending function. And then I can call this to the coroutine builders. And in case you want to use it directly right in the coroutine builders, then that's also possible. So that's it in this video, and in the next video I'll talk about the difference between launch, async, when to use launch, when to use async, and when do these functions are helpful for us. So to get the notification about those videos, do not forget to subscribe this channel, and if you have liked this video, then do hit the like button. Thank you and stay tuned.